by 3dprint.com. So today we learn that Alloy Enterprises has raised money. The company has raised into 26 million from Piva Capital, Unless, Flybridge Capital, Mass Mutual Catalyst Fund, Footprint Coalition, Congruent Ventures, and Riot Ventures. This is a Series A round. The total funding now is 37 million, with them raising 26 million today. This is quite remarkable. It's a very tough time to raise money, so it's very good for them that they managed to scrape together money in this market. They hope to use this for further automation and to pump up production. The company was founded in 2020 to commercialize essentially LOM for aluminum. They do laminate object manufacturing in a kind of different way. They essentially laser cut, as you see an image, they laser cut a part, then they selectively apply a binder, then they stack the sheets, and if you see in the next image, then they're diffusion bonded, right? And then the support material is broken off. So it's a diffusion bonding, laser cutting, kind of long process based on aluminum sheet. Now, of course, we all know, based on the experience with LOM, it's very cheap feedstock, and this makes it potentially very inexpensive process. I worry about this last step, this breaking out the support material. I can imagine that in an industrial scale that could be quite complex and quite labor intensive, or quite difficult to do, or quite time consuming overall. But essentially this is MCore for metal, and it's a new way of looking at things compared to other processes. It's very limited in geometric freedom when compared to powder diffusion, but it's way, way cheaper. So if they manage to find the right part families, then they could really face a great future. They're one of a bunch of companies now with Surat and Vulcan Forms coming out promising to industrialize metal 3D printing as a service with new technologies and lower cost ways of doing things. And this, if successful, could really push our industry forward into many things. The company's also talking about targeting automotive and industrial and things like heavy equipment. Now, especially in heavy equipment, these are kind of parts that we normally can't make, and they could very well be very well served by parts from this process. This could be very, very low cost technology. So this could be something that really expands additive and what additive can do. The next thing is MetalWorm. So MetalWorm is a spin-off for a Turkey-based company called Baked Interco Robotics Inc. And this has now released its machines. They're wire arc additive manufacturing machines, which is I kind of jokingly call it a FARNet shape 3D printing technology. But it's a 3D printing technology uses inexpensive feedstock to print using wire arc additive manufacturing, so a very known technology, wire arc welding, and they use that to build up an object, and then later on this object nearly always has to be milled down to then be net shape. Wire arc is very inexpensive, can be used for quite large parts, can be incorporated and joined with a lot of different technologies, and you can also make kind of interesting combinations of metal for it. So this is it's nice to see more vendors coming out in this DED, directed energy deposition wire arc space, and to kind of make it kind of more plug and play nowadays. What's notable is that the company says that they're doing stainless steel, and aluminum alloys, all par for the course, and they're also doing armor steel. And this is it's interesting that they mention this, because it's not usually, well, we know that people are doing armor with 3D printing, but it's not usually dropped in a press release kind of thing, and people don't really talk about it. And especially in DED, we can think of armored steels making duplex, or making kind of steels with backing. So you can print a complex component for, let's say, an armored vehicle, which could then be made out of multiple layers or multiple materials stacked on top of each other to end up being a much more powerful and much more resistant armor steel, kind of composite material. And this is very, very cutting edge, and would really bring a very low cost way to armor vehicles and to repair them also to a lot of things. Now, indeed, some of the company's customers kind of point to maybe people doing this already. One of their customers is Roketsan, which is a leading Turkish producer of missiles, artillery, weaponry, and artillery missiles, and that kind of thing. Another one is Otokar, and Otokar is an armored vehicle producer. Another one is FNSS, which is another armored vehicle producer as well. which is partially owned by BAE, the English defense contractor BA or BAE. So generally, we're seeing that this maybe have a lot of military applications, and especially with this being able to use different alloys together, especially being able to make larger parts, this could very well be very useful for arming armored vehicles and other kind of things like that. The next news is also out of kind of has a military bent, and that's from Senvol. So a US company, Senvol, has kind of made its business to harness, to collate, to collect, and to distribute data. And it's become like kind of an unmissable component. So it's a very, very smart play by them. They've recently got a contract by the US Army for applying machine learning to ensure consistency and verification of additive manufactured machine and part performance across multiple sites. Now, if successful, this 2-year project hopes to tackle essentially one of the biggest problems in additive. We have to all qualify parts and materials or machines, and often what we realize is that we have run-to-run differences between machines or between batches in a machine or a production run. And so the central promise of additive, or one of the central promises of additive, is that we can make spare parts. So you can print out a spare part for a tank in Germany and in the United States on the same machine with the same material. Now, in reality, this is not the case often, and we need to do a lot of work to make this happen, and it's very difficult. Also, there's a problem with if there's a new material supplier, for example, on the market, or you change your machine, then you have to do this qualification process all over again. So this could be really complicated, especially if you've got large kind of libraries of parts and also different materials and things like that. So this is a really key project for Senvol, but also for the rest of us, because this really, if Senvol learns how to do this properly and quickly, they could have like kind of like a settings translation engine or a qualification engine that would make it much faster for people to qualify parts and to get consistent print runs out of like different machines trying to make the same parts. And this is very, very important. It will save everyone a ton of time. So that's also, I guess, military again, which is again worrying that we're being used for so many military applications, but all in all, that's good news for the technology in and of itself. I hope you found this useful. My name is Joris Peels, and this is another edition of 3D Printing News Unpeeled.